Okay, hi everyone. Today's discussion is about rovers for newbies and how to start rover robotics with any budget and any skill. So today's agenda is, so first we'll go through various kinds of rovers in different budgets you can make. And then we'll also quickly go through the 2021 builds, what we did in the last year, and then some open discussion and Q&A. So let's start. So if you have no money and don't want to spend any money, and then the easiest way to start robotics is start with a simulator. So there are various simulators in the market. Some of them are free, some of them you have to pay, and some of them are listed here. So Gazebo is the simulator which comes with ROS. ROS is the robot operating system, and it's one of the first things you'll hear about when you search for an operating system for robots or rovers. So it's plays nicely with ROS. If you're playing with ROS, then Gazebo is the simulator to go. And this is the build which I did and the simulation of it. So this is the Gazebo simulator, and then I'm able to teleoperate it inside the simulator. So when I actually built the actual rover, I was able to control the actual rover with the same software and then test it beforehand in the simulator itself. And you could also create different kinds of terrain inside the simulator. So this is like simulated Martian terrain. And then the other simulator one could try is called the Coppelia simulator. It used to be called VREP, and it's from a company in Switzerland, and it's really beginner friendly. I personally like it a lot. So the advantage is also it's like beginner friendly, and then you don't need much programming experience to start playing with Coppelia Sim. And the scripting inside is mostly with Lua. So Lua is a programming language similar to Python. It's much lighter than Python, and that's why it is used as an embedded scripting language inside other engines. So let's look at the various kinds of simulation we can do with VREP. So this is one of the hexapod robots which you can simulate. So this is similar to what one of the or two of the builds in the last year were hexapods. So you could also simulate the hexapods in this simulator.
Anuraj, what's the programming model or language for Gazebo?
Well, you can program it in Python or C++. But I think, yeah, it's mostly Python and C++. Yes. So there is no embedded scripting inside, as far as I know, because I haven't played with simulators for a very long time. And the latest was this Gazebo Sim. And mostly it was like just running the Python scripts. And I think they have some remote procedure calls available. So you can like send commands inside and set up a ROS node inside the simulator, and then you can communicate. So it basically becomes a node. So the node which runs on the actual rover, you can run it inside the simulator. But if you're a beginner, I would really recommend VREP. I don't know why I like it, but it's like I think in 2014 and 15, I played with 5 or 6 simulators, and Coppelia Sim was like one of the best ones I used. Ease of use, and it's like the Python of simulators. So it gets you started really fast, and then it integrates with ROS with various APIs, and then you can do a lot of complex simulations inside VREP. And I met the guy. He came to a conference in Oulu, and it's a one-person company. So there's one guy who was writing the entire simulator, but it's far better than many other simulators I've seen. And yeah, really nice guy. And he, if you ask any questions on the forum, he replies quickly. And then in Coppelia Sim, you can also have different kinds of physics engines installed inside. Yeah, so this is the laser scanner simulation. And the other simulator is called VBots. I think VBots, I tried it last year for maybe a day or so, but VBots, at that time, I didn't have a really powerful computer. So the one disadvantage of like using simulator is like you need at least some decent computing power in your, otherwise the simulation will like hang or become really slow. So the fidelity will decrease, and it will become a little annoying to use it. And I wanted to try VBots primarily because it had the spot model bin inside. So if you wanted to play with the Boston Dynamics spot, so you could use VBots. It has a API inside, and then you could install it, and then you could play with spot. But yeah, I'm not much familiar with VBots robot simulator. Did my screen share shop? Is my screen share still on?
No.
No, it collapsed.
Okay. Let me share again. Okay. Now it's visible, right? Yeah. So that was about starting Rover Robotics without any money, or let's say if you have a good computer, then and you want to start playing with rovers, then simulation is the maybe the first step. And if you are really a beginner and don't want to do much programming, then Coppelia Sim is the way to go. But that's my personal opinion. Somebody might say like Gazebo is much better, but yeah. And then the rover budget of about $50 to $100. So this is one of the robots you could build in this budget. It's called Otto, and this robot can be built in various forms. So this is the humanoid version of it, and there are also wheeled versions. Let's see the video of it. They have released or are going to release a new version of it. It's called the Otto Ninja. So it's a bipedal plus wheeled robots. So it's like a small transformer that converts into either a humanoid or a wheeled robot.
Learning how electronics work. Otto Ninja mobility is in a class of its own, from spinning to dancing to transforming. Who says learning about engineering isn't hard, right, Otto? After you build, then comes the fun part of putting code into Otto Ninja's brain. Otto Ninja is compatible with both Blockly, Scratch, and Arduino ID, allowing for simplistic learning through block-based coding for ages 7 and up. Or, for more advanced coders, Otto can be programmed using C++. Otto can sense movement and objects as if a real person, by programming sequences for it to react. Now that's pretty cool. And that's not it. Otto Ninja comes with a remote-controlled app allowing you to have fun controlling your Otto's action in real time. Whether racing or making a battle, Otto Ninja is a fun toy too. Want to have a more humanoid experience? Order Otto Ninja Humanoid, giving Otto servo-controlled arms with grippers to hold tools, allowing for fun battles.
Yeah, so this is a fun robot. And yeah, and this is the Omniwheeled version of it. I think so this is 3D printable versions. You either buy the kit or you buy the entire 3D printed. So they sell both. So you can either buy just the electronics and the sensors from it and then 3D print the chassis and the other stuff. Or you could buy the entire stuff and they will 3D print it for you and then they will send it. And this is highly customizable. This is someone has put, instead of the wheels that is there in the standard design, they have designed their own Omni wheels and put on the robot.
Hello, this is Omni 4. As you can see, you can't quite see the back wheel, but he's a 4-wheeled robot. These are Omni wheels with 6 rollers on each of the plates. And he's controlled using a simple app developed on the MIT App Inventor. So I'm just going to demonstrate the motion of Omni 4. So first thing you need to do, of course, is connect him. So go through this. So this is connecting to the Bluetooth. Have clockwise and counterclockwise rotation with this type of bot. But we also have nice diagonally forwards motion, diagonally backwards motion.
Yeah, so those were robots which you could build in around $50 to $100 and easily programmable with Scratch or Blockly. So Scratch is a programming language, visual programming language. I think it was developed at MIT for kids to program, to learn programming. I think it's like Logo. I think I started with Logo, but these days kids start with Scratch, something like Scratch. But it is also programmable with Arduino and all the drivers are available for it. So if you want to do more advanced stuff within this budget, this is the robot I would suggest. And then the next is, if you have a budget of about $100 to $500, then these are the various kinds of robots you could try. So 2 of these were there in the builds last year. We'll go through them later on. And okay, all 3 of them were there in the builds last year. So the Sunfounder PyCast was used in a build by Victor. He's not here at the moment, but they are basically Raspberry Pi based 4-wheel robots. And I think a lot of drivers and other software is already available for them. And this is the DJI Tello robot, or it's a drone, which I combined with a rover in my build. It's in the build. The build is called Infinity and Beyond, and it's available for $250 approximately. I think now the price is a little bit less, so it's around 150 or something. So it's a little less cheaper than this, but the red one which you see, it has a little bit more extension for and it's used for robotics courses in many parts of the world. So that is a little pricier, and that extension is like $50 to $75. So that price total becomes around 250. But if you buy the cheaper one, then you can program it in Python, and yeah, so and then it also has a camera inside, so you can also take pictures and do computer vision and learn computer vision with this drone. And the last one is NVIDIA Jetson. The budget is around $200 to $300. This is one of the vendors' budget. I think you can also buy something for around $500 from different vendors. So this is from Waveshare. So they have taken NVIDIA Jetson and assembled the motors and other stuff to make a robot out of it. But essentially, it's similar. I would say it's similar to what the Pi cars are, but more geared towards machine learning robotics. And like and the Pi car is a more general robot. So if you want to just get started, I would recommend the Sunfounder Pi cars, easier to get started. But if you already have some machine learning knowledge, then maybe and a little higher budget, then NVIDIA Jetson might be the way to go if you want to play with the AI and machine learning and deep learning. Yeah, so that was the budget, $100 to $500. And there is something also called Ducky Town. It's, I think, it's from ETH Zurich or somewhere in Switzerland. So it's a learning platform similar to the other Pi cars. Okay, there is no sound, I guess. Yeah, it seems similar to Pi cars. And it's used in some of the universities in Switzerland.
That's a lot of ducks. I wonder what the backstory of the ducks is.
Yeah, actually, I don't know. But it started, I remember it started with one of the ICRA or EROS conferences. So ICRA and EROS are one of the largest robotic conferences. I think ICRA is International Conference for Robotics and Automation, and then EROS is similar, something robotics related. They are the two largest conferences and it started at one of them. And then if you have a budget of around $500 to $1,000, then these are like two of the robots you could build. The ESA robot is more hands-on, and the DJI one is more built, and it's yeah, you can program it a lot and it's more sturdy and you could do a lot of other stuff. But if you want to do more hands-on stuff, then ESA robot is the rover is the one you could build. This is the one I built last year. Yeah, so so the budget is around, it says that you could build it in less than 500, but the budget crosses 500 just if you are really tight. But because you have to print many times and then you make some mistakes, so budget generally becomes between 500 to 1000. And it's all the software is available for it, so it's quite if you follow the instructions, most of the people could build it if you have some programming experience. But you need some programming experience for building this, because it runs on ROS and Docker. So if you're familiar with it, but it's a good learning platform. And also, if you want to learn mechanics, you basically can do some stuff with it. And if you know some CAD, then I've seen some people modify the mechanics of this rover. I don't have enough mechanical knowledge to modify this rover, but hopefully someday I'll know something. So this is by building the ESA rover, you get to play with the entire stack. The mechanics, the electronics, the power electronics, the low-level embedded software, and also the high-level navigation software. And by adding some machine learning specific CPU or GPUs inside, you could also do some machine learning. So it's like entire. If you want to learn robotics and do the entire stack, ESA Exomai rover is the one to build. And this one is from DJI. It's a ready-made platform. So this seems geared towards like more as a toy or for advanced software programming.
Meet the RoboMaster S1, the smart educational robot that opens up a whole new world of learning. Experience fast-paced driving action, whether you're by yourself or with a friend. Something in the way? Check this out. With the Mechanim wheels, your movement options are limitless. From the brushless motor to the front axle suspension, every inch of the S1 is jam-packed with advanced technologies. With the included interactive curriculum, anyone can learn how to code. Teach it to move, recognize shapes, and a whole lot more. Apply math and physics and take your S1 to the next level.
Yeah, so this seems a little more less programming specific, and then more like a toy. So maybe for kids, but in this budget, if you're like really want to get your hands dirty, then ESA robot is the one to build. And if you have more budget than that, then NASA has released the JPL rover, which you could build in $2,500. It's completely open source, and it's a really big rover. The size is okay here, this one. So it's yeah, it's I don't know if anybody is building this or not, but it's a big rover. And if you want to do some real experiments outside in the desert, then this is one of the robots one could build. But the difference between this rover and the one by ESA is that the suspension is different. The NASA rover is rocker bogie mechanism for the suspension, and the ESA rover is a triple bogie suspension. So the difference is that the entire body is hanging on 3 separate bogies, and in the rocker bogie mechanism, there is one rocker and the other one is a bogie, and they are connected by what was that mechanism called, Venkat? How are the wheels connected?
It's a differential bar.
Yeah.
You've got one rocker bogie on each side, and then there's a differential bar connecting the two.
Yeah. So in the triple bogie suspension, there is no differential bar between all the bogies. And if you want to do some
just 1 second.
Yeah.
You've been talking about price and money.
Yeah.
But these, can you give us a feeling for how long it takes to print the robots we've been talking about?
Okay, so the robot I built, it actually, if you count the number of hours spent, you could say maybe 3 or 4 weeks, but I spread it over such a long period of time. So it took me, the entire build took me around 8 months, but because I was doing it only on weekends or maybe whenever I felt in a mood. But if you are like, for example, the chassis, it takes around 24 hours with a good quality print. So it's not continuously 3 or 4 weeks of printing, if that is what you are asking. So the total print type might be around, let's say, 3 or 4 days. So 24 hours, but that is, I'm talking about with 40% of infill. So whenever you are 3D printing, so you can specify the amount of infill you need or the density of the material you want inside. And then that changes the print times a lot. So the main chassis in which holds the computing unit for the ESA rover, it took me 24 hours, and then each of the wheels were around 6 hours. So 6 into 6, so it's 36 hours more. And the others were like 2-3 hours each, the other components. So I would say 3 or 4 days of total printing time. But nobody, I think, prints that fast unless you are in a 3D printing factory. And the 3D printer I bought, its price has reduced right now. So I think I bought it for around $300, and now it's running at around 200. So there is a sale going on. So the one I bought was called Anycubic. So if you want to, and if you want to print this ESA rover, so there is a specific dimension of 3D printer you need to buy. So if it's too small, you cannot print all the parts. So if you buy the Anycubic Mega S, it has the dimensions required for printing all the parts. So last I saw an Instagram ad, and it was running at around $200. So it's becoming cheap quite fast. So within 9-10 months or maybe 12 months, it has reduced by $100. And for printing Otto, it took me maybe like total print type might be around 1 day, or maybe like, yeah, around 1 day. But I printed it over maybe a week on different days. So the chassis, like the main body takes around 3-4 hours each, and then the legs are like 1 hour each. But 3D printing is a slow process right now.
In my experience, even if you're printing like designs that you download from elsewhere, the 3D printing time, even though it's a lot, it's not actually.
You muted yourself.
Oh, sorry. Yeah, the 3D printing time, unless you're like doing really, really big jobs, I wouldn't say it's the main time commitment. Even if you're working with an existing design, things like reprints, then assembly, getting it to fit, putting the electronics in, and then all that takes like at least as much, if not more. And I think my guess is the software and other parts of like getting it to like even hello world level functioning is probably an order of magnitude more than the printing. So my guess is something like printing, if it's 1, then multiply by 5 for everything else that's mechanical and assembly, and then multiply by another 10 for like software and electronics debugging. That's my guess from what I've experienced so far.
Yeah, so people are able to build this in a month or 2 because Isa has spent like 2-3 years building this. So they have the entire software stack really nicely done, nice scripting. So anybody all with a basic programming from other fields of programming can directly come and start printing, and the software stack is ready, and then you can build quickly. So they have spent around like 2-3 years and released everything is open source, and now people can build it in a month or 2. Even less actually. If you are like doing it full time, you would do it in 3 weeks. And this is the unitary. If you're into quadrupeds or legged robotics, this is one of the robots you could buy. It's a cheaper version of Spot. One of my lab mates has been playing. My previous lab mates has been playing with this. I think if you have even more budget, I think there's one from Huawei for around $15,000, a similar one, maybe more expensive parts, which you could play. But yeah, so this was a quick introduction to the starting robotics in various budgets. And let's quickly go through the various robots we built. All these the robots we built is on our YouTube channel. So if you go to our YouTube channel, the Yak Collective, you should be able to see our weekly meetings, and also we have put our rover demo and annual meeting YouTube clips on YouTube. And then also the demos, there is a specific playlist. This is the one I built. I didn't have enough time to assemble the head and the camera, and I'm controlling this rover via my computer on a browser. And now I'm trying to control the drone. The drone was controlled with the Python script. So the command was just to take off, maybe stay there for a second and then land. Maybe Mayor could say what the rover, his rover was trying to do here.
The rover here is walking up and down the garden path in order to collect information for us to do some kind of machine learning on what movements have what effect on the robot position. And it's using a gait which allows it to walk on uneven ground. The six-legged hexabot from High Wonder.
Mayor, how much does this High Wonder cost?
I believe it costs about $500.
Maybe Red could speak to this about your rover.
Yeah, no autonomy here. This is all remote operated over a packet radio. And yeah, I can just explore my office floor. It does have a camera on it that can very slowly download photos. And it's based on Arduino. And the mechanical system is from a kit, but all the software is custom, and all my wonderful wiring diagrams, all my wiring decisions are more me.
This is the build by Sai. He's not present here at the moment. So this uses the NVIDIA Jetson kit, and then he had trained it on some other terrain, and then he was trying to have the robot explore his own room. So the robot is trying to avoid some obstacles whenever it finds one.
These joins that
Okay,
you see
this
between
is
aluminum and 3D junctions. The reason I went with the strategy is I want to do modularity and extensibility. And in the future, if I just want to make this rover much larger, if the electrical harness can actually handle the distance, I would just like replace the tubes and make it longer. And then you'd get a bigger rover and, you know, interchangeable parts and so forth. You've got the SG90s in there. You've got the drive motors. I don't know if you can see very well. You've got the N20. There's a 1:100 ratio thing. You've got the. I haven't yet hooked up the wires for the motors themselves.
okay. That was
These joins.
that was Venkat's robot, and that build was concentrating a lot on the mechanical aspects. Venkat, if you want to speak to that, about your build.
Yeah, so this one I designed from scratch myself, and it has some problems, mechanical problems that I have to fix before I can actually run it properly. But since we're talking a lot about cost, I can give you a rough cost estimate. I would say the 3D printing filament stuff is like just a few bucks. The most expensive component is the BeagleBone Blue single board computer. That's between 80 to 100 bucks. The four N20 motors with Hall effect sensors attached cost about 13 bucks each, so about 50 to 60 bucks. And you get like the SG90 motors are really cheap. There are servos for steering. I have 4 of those. So let's say another 10 bucks. So I would say computer, 100 bucks, electronics components, about 70 bucks. Probably wiring and miscellaneous, another 15, 20 bucks. Battery would be another 10 bucks. And I have some aluminum tubing there. That's like maybe 10 bucks. So I'd say the overall build, raw materials, if the design were perfect and validated, you could probably build it for like under 300 bucks. But since it's not validated and I'm making lots of mistakes as I go along, I think I've spent maybe 400 or 500 on it already, like burning out motors and like breaking things. So, but there's I would say in the $200 to $300 range once I get it right. Did well.
And this was a small competition on our demo day. Eric and Maya had organized this. So we were controlling these rovers remotely, and the rovers had to knock off these the stick on the bottles. So let's see how it went.
I positioned about the same distance they were before, okay?
But it's pointed in the right direction. So like 5 steps, it should knock over.
But
Almost.
why is... Oh, a little bit more.
Little bit left, I think. And then a couple of steps, it should be done.
But which is this rover that is coming closer?
This is
Not
AFW.
yours. Oh no! Oh no! Hey, can we see AW?
Oh, this is
Left,
a
left.
nail biter here.
Oh, this is close.
Okay. Somebody's there doing a high walk. I think that's AFW doing a high walk.
It's the high walk is LI.
Is that all right? Yeah.
Yeah, it's a lie.
Okay.
Oh, this is getting close.
that is me controlling it.
All right.
Yes.
Oh,
Somebody do it.
Yes.
No.
Yeah.
yeah, this was a fun event. All of us were trying to control these rovers from different parts of the world, and it was quite challenging to coordinate the movements of the rover. So this could be like one of the learning experience, how we control when the actual rovers are there on Mars or Moon. How would you give commands to them, and how would you know if something has gone wrong? So this was a small teaser for it. Yeah, so that was today's presentation about rovers in different budgets and different skills, and what all things you can do in different budgets. And we also went through the different builds last year. So any questions, discussion?
I had a quick question about the simulators. Are you building your own robot in the simulator, or they give you pre-programmed robots?
Well, you need to build, for example, so there's something called a URDF model in Gazebo, which simulates the joints and axis, and then you can import a STL file on top of that URDF file. So you don't need this, let's say the robots you see here. Let's see. Yeah. So the robot which you see here, it's actually, you don't need the entire thing if you want to just simulate the robot. So you can, this can be simulated if you don't want the outer physics simulation, and then you can just have the joints and URDF and the outer, let's say, borders of the rover, and then you can simulate it. And this is like a shell, ICL shell on top of the joints. And I think Coppelia Sim has a lot of inbuilt robots inside, so you can just drag and drop inside. So you don't need to build something, but you can do lots of complex stuff. If you go to the YouTube channel of that simulator, so when I met him, I asked him if he has done all these yeah. So this simulator has its own YouTube channel, and I asked him if he has done all these simulations. He said no, somebody just when he released the initial few, people who are around the world were doing these simulations, and then they were sending it to him. And then some of the simulations, like he didn't even imagine that it could be done. And then somebody else has done it. I think there's one good one somewhere. So this is the Now simulator. So the bar which you see on the left, if you just drag and drop it inside, the robot will appear in the simulator. And yeah, these are the different kinds of simulations you can do in Coppelia Sim. Any other questions, comments?
And then for the ESA package you mentioned, you 3D print the parts, the electronics is, they sell that or you have to source that?
So
yourself.
you mean, can you see my screen? Maybe it's not.
Yeah.
Wait. So if you go to the Otto DIY website, so they have like two kinds of builds. One is the maker build, and one is the and one is called the maker, and one is the builder. And I think the maker you print it, and in the builder you also print it, and in the maker you just buy the electronics.
Okay.
Were you asking about the ESA one
that one, the ESA one, yeah. Do they give you the
okay,
electronics on that?
that you have to buy. I bought a lot of the stuff from Amazon. So when I was building the ESA rover, so they suggest a specific shop, and the entire thing is the mechanics and everything is designed according to like the sizing is all done according to the components you get from that particular shop in Netherlands.
Okay.
So for example, the battery, it has a specific dimension, and the screws and the holdings which you use to pin down the battery to the chassis is designed with that battery specification in mind. So if you buy a different battery, then some of the parts you might have to redesign, or you might have to do some mechanical changes. So what I did was buy everything from Amazon, and then I used double-sided tape to put everything inside. But I could change the dimensions of those mechanical parts to fit it inside. That could be done. But I just started learning on the Onshape, and I went through just maybe half a tutorial. So learning it.
And what is the board or computer?
The computing is Raspberry Pi.
Okay.
Does anyone have any experience with like build systems? Like, I guess Lego Mindstorm was the thing for a while, but I just kind of wonder if there's other, like they're kind of toys, kind of just like, how do you build stuff that's components that snap together?
I haven't seen Lego Mindstorms being used, at least in academia, for some time now. 10 years ago, I used to see it. My lab had it, but after that, yeah, it isn't there anymore.
Yeah, what if, does it exist or is it unpopular?
I've seen it in Lego shops.
Okay.
Lego Mindstorm still exists.
Yeah, but
It's
they are not
called
as
NXT
popular
now.
Yeah.
Vex is another one I've seen that has a lot of educational kits. I'd actually have a Vex kit, but it's like probably a dozen years old now. But it gives you it's modular, so it's like wheels and tracks and servos, and you can combine them in different ways. But I don't know if they're still around. is VEX.
Yeah, so First Lego League and US First are both still around, and it's no longer Mindstorms. It's NXT. Lego NXT is what they're calling their robotics bricks and kits. I believe First Lego League uses NXT. Don't quote me on that, but yeah, I don't know if you can program the current generation Lego brick with C. There used to be a C-like language that you could program the Mindstorms RCX brick with, but I mean that you still can today as well, but it's not something that you can buy new anymore.
There's no
Sounds like
Arduino brick.
now, if you were to try and do something similar today, you would build it around the Raspberry Pi. Like you would not do anything that kind of vertically integrated single company thing. You would build something around a Raspberry Pi, 3D printable mechanical parts, and maybe you would at most sell electronic or motors and sensors as a package. So really, the equivalent of a Mindstorms would be a sensor and actuator kit, with everything else being either open source design or RPi. I mean, I was thinking at some point, like if we get good enough, we should try and make a kit to distribute. And if we did that, that would be the minimum viable one I could think of.
Hi, Fabian. Brian, if you have questions about, or Venkat, if you have questions about gazebo, I think Fabian is a gazebo expert. So he was participating in a NASA competition and making really cool simulations in gazebo.
Yes.
Can you show something quickly? What you had?
Show something. Let me look around if I see something. Give me a few minutes.
So Fabian was competing last year in a competition organized by NASA. I think it was lunar simulation, right?
Yes, so last year there was it was called Space Robotics Challenge Phase 2, and it was a simulation. The simulation was done by on the NASA side by some company, and running on gazebo. And what we were doing is more controlling rovers inside the gazebo environment.
So Fabian had a presentation for us last year, and that video is already on our YouTube channel. So if somebody wants to watch it, you could go to our YouTube channel and then watch the entire presentation by Fabian.
Oh, I didn't know I was on YouTube.
Yeah, we have a good YouTube channel now. Like and subscribe.
I have a question. I don't know. When I bought the Lego Mindstorms, I guess it was maybe 20 years ago, 15 years ago, it felt unfulfilling. And then it sat back and gathered dust until one of my kids was old enough to play with it. And that also did not last very long. And I'm having difficulty putting my finger down why it felt unfulfilling and why it didn't get more attention. I'm thinking maybe because the mechanics were too complicated.
I think it was because of the ecosystem. I think they were tying you down to specific things.
No, that it was good that I had all the parts and I could put them together. But the mechanics themselves, if you wanted to build something mechanical, you had to use these Lego Technic parts. And except for some very specific designs, it was very difficult to modify and get a different robot. So you built a robot that could follow a line. But if you wanted it to do something different structure-wise, you had to redesign it from scratch. So I'm just wondering if anybody else has a similar experience with Lego. In other words, it's good if you want to teach people and you give them a series of steps to follow, because it's Lego, anybody can put it together. But if you want to do exploration, so the hardware seemed, difficult to modify designs, and the software didn't seem to do anything interesting. So I could follow a line, I could move faster, I could move slower. When I banged into a wall, I could change the way I react. But that, I don't know, got old.
What was the programming language for it?
Oh, they had a C-like language and they had a graphical language. But like I said, the problem wasn't the language. It wasn't that I wanted to tell it to do something and oh my God, how will I do that? It just all seemed, you know, like when you walk around wearing ski gloves. It didn't draw me in to do things. I'm just wondering if anybody else had a similar experience, because in the end, when somebody goes into robotics, they want a hobby and they don't want to fear. Well, some people do like very big challenges, but they like feeling like if they try to explore, they're actually exploring and doing something.
I think I had the same reaction. I played with it once. I never had one, but I played with it once. And I think anytime you have like a closed sort of mechanical ecosystem, especially, like software is very flexible. Like even if it's a very proprietary language, fundamentally you can do lots of open-ended things. But the mechanical components, if you're sort of restricted to a fixed universe, it sort of becomes uninspiring after a while. And what I think actually works, the example I'm thinking of is the remote controlled airplane, and more recently the remote controlled monster truck hobby scene in the US. That seems to have a very interesting structure because it's not by one company. It's not all the parts coming from like, you know, Lego. So if you go on Amazon and look for monster truck parts, there's like dozens of vendors instead, including aftermarket Chinese companies. So you can like buy all sorts of components, but still you're still within the same scene and you build like similar looking monster trucks. But it's not, I wouldn't call it robotics because it's basically remote control toys and they don't do very sophisticated, I don't think they do any programming. It's just a radio receiver for basic controls. But I like that kind of feel, because that feels like you could endlessly explore. You could keep buying more components, design your own, keep building. So that something like that, I think, has a more better inspiration loop. Lego does have an open community these days. Did you guys see that thing about a guy who used Lego parts to build mock-up of the James Webb telescope? So it's really good. It's like highly accurate model of the James Webb telescope. And now, since it's a community design, Lego is now evaluating it to turn it into a kit. So it's a little bit curated and they kind of manage the process of turning it like ideas into kits. But I think fundamentally one company controlling like a system of kits is, I don't know, dispiriting beyond a point.
Yeah, I think that just one counterpoint on the hardware aspect. Maybe you saw some video. Every time I open LinkedIn, I was seeing them recently. But there's some people, I think, part of some Lego community, making some experiments. And this one is trying to make a robot climb hard obstacles. And they show how they can change the wheel size, etc., to try to make it climb. So it shows, I think, some level of flexibility in Lego. However, where it is simple here is that the robot only goes straight, which makes it rather easy. As soon as you want to turn, etc., I think you have a lot more constraints with Lego techniques. But so from the hardware, I think there's still room for experimentation when I see that kind of video. And for the Lego NXT software, I've never used it, so I'm not sure.
I posted the link you were talking about in chat, Fabian. I think this is the one you're referring to. Yeah, I've seen it several times as well. And that's definitely actually a good thing for, I think, beginners to look at for inspiration, because it shows you the challenges of what a rover actually is.
Did you find something about your own simulation, Fabian?
Yeah. I'm still looking into it. I have it's funny, I need to prepare that. I never have the video ready.
We can check our own YouTube channel.
Okay.
Anuraj, if I wake up in the morning and decide I want to get into robots, where should I start? Putting aside the budget, I'm not a very technical person, but I want to learn and build a robot. Where do you recommend I start?
I would say go with Otto DIY. It's really beginner friendly, programmable in Scratch. And if you want to jump to a higher level, you can program it in Arduino and C++. So it's really made for robotics education.
And would I get the complete kit or the 3D
Yes, if
print?
you see my screen.
Yeah.
So this is the electronics kit. So I got it in 55 euros. So maybe 60 or $65. And then you can buy this, and I just printed the body and legs. And yeah, you can play with it. And then you can also attach various like ultrasonic sensors, or if you want to have a face, then you can attach a 8x8 a LED matrix and then make it smile. So it's I would say for a beginner, it's a lot of fun. And then you feel like you have accomplished something, and then you are you will get a sense of progress if you are using Otto.
And I can also buy the part, or do I have to 3D
If
print?
you don't have the 3D printer, you can also buy with this kit, they will send you the printed parts. So if you don't have a 3D printer, then you can buy this kit along with the 3D printed parts. So they sell it together. But I think it costs like $20 more, but that's not an issue. Yeah.
And how long would it take me to get through it as a hobbyist who only has time on weekends?
Within a month, working every weekend, I think 4 weekends should be enough to at least make it walk.
Okay, so after about 3 months, what should I graduate to?
You should be able to avoid obstacles in 3 months on working on weekends. I think there are examples. So if you are just running the examples, and it has an online community as well. So you can go to their forums and the Otto forums, and then post your questions. And if you don't like programming in C++, program it in Scratch, play with the visual blocks. And then if you are really into mechanical, modify the body, make a ninja out of it. I like the Otto Ninja. So it is a wheel and a humanoid, both.
Do they sell it white label that we can brand it?
I don't know. I think that Otto is a brand itself, and so I'm not sure.
I'm just wondering if you could have the Otto Yak. If this is a good, entry point. So.
Yeah, we could actually but yeah, I don't know the details. I just bought the kit. So and they have an office in US and I think somewhere in Spain here. Actually, we could make a small like a model of it and import it in for making it available for import in the simulators, and then people could play with it. Because I think two-wheeled, let's say, with a two-wheel robot model should already be there in the different simulators. So we just have to replace the outer body. The joints and stuff should already be there inside many of the simulators.
So what you're saying, it's a starter kit that includes both the robot
and the simulator
a simulator with a robot inside.
Yeah, if you want to provide a kit, something like that. But I think somebody could have done the Otto simulator too. So not sure. Okay, we are approaching the 9 o'clock mark, or 1 hour 45 minutes. And I'll have to jump out soon.
So, anybody have any other questions or insights on the subject?
No, but I think this is a topic we should keep revisiting like every 6 months or so, because maybe once a year, because it seems to be a very fast changing, fast moving kind of like space, the entry level, what's possible and stuff. Like some of this seems to have just appeared in the last year. So yeah, it would be good to do a Rover newbie session every year, maybe.
Next week's session is by Mayor or?
No.
Okay, we can decide that in Discord.
Yeah.
Okay.
All right.